So the second question says on the same set of axes, sketch the graph of g, the inverse of g. So g to the power of minus 1. And in this case, we just invert all of our coordinates. So as you can see, the x coordinate here is 1, the y is 0. Over here, it will be the y will be 1 and the x will be 0. So that will be our point. I can put it in a different color there. And then the next one will be 2 and 1. So this one will be 1 and 2. Something like that. The next one was 3 and 2 comma 5. Then it's going to be 2 comma 5 and 3. Something like this. And the last one was 4 and 2. Actually, this one is 3 and 1 comma 5. So it's going to be 1 comma 5 and 3 somewhere here. And then the last point was 4 and 2. This one's going to be 2 and 4. As you can see, this one has a inverted shape, and it's inverted along the point y is equals to x. And we can extend our function. We know that exponential and logarithmic functions have asymptotes. I hate when it does that. Okay, something like this. This could be a function, or you could just extend it from this point if you want it to look smoother. Then take it back. Just as long as you're not crossing this, I can't draw mine as smooth, but as long as you're not crossing the x-axis, you should be fine. And on your logarithmic function, as long as you're not crossing your y-axis, you should be fine. So this is your inverse graph of g. Just invert all your coordinates. Everything about the inverse graphs is just inverted, so it's swapped. The x becomes the y. This is because it's a reflection line along the line, or it's a reflection along the line y is equal to x, which looks something like this. So when we go from one to the other, we just swap our y with the x. That's why the exponential has an x asymptote, but the logarithmic has a y asymptote. They just swap values.